Friends, in this lecture we are going to see Fourier transform. Fourier transform of a function f of s. So Fourier transform of some function f of x is equal to 1 by root of 2 pi integral from minus infinity to plus infinity f of x e to the power I s x dx. Now by doing that we are finding out f of s, which is the Fourier transform of f of x, and we are moving from x domain to s domain, or you can also write the x space, the space which is for x, the position, to some other quantity s space. Okay, so this is how you take the Fourier transform. Now this is from x to the x domain to s domain. If we want to move from x domain to k domain, we have Fourier transform of f of k equal to f of x equal to 1 by root of 2 pi integral from minus infinity to plus infinity f of x e to the power I k x dx. By doing this you are moving from x domain to k domain, f of k. Now similarly, if you want to move from t to omega, Fourier transform of f of t equal to 1 by root of 2 pi integral from minus infinity to plus infinity f of t e to the power I omega t dt equal to f of omega. By doing this you are moving from t to omega. Generally it is called time domain, and omega is nothing but the energy domain, or energy is proportional to frequency, so frequency domain. So energy and time domain. Now there are Fourier sine transforms. Fourier sine transform. Now here fs of Fourier sine transform of the function f of x is equal to root of 2 by pi from 0 to infinity f of x into sine sx dx. Now this is a Fourier cosine transform of f of x, that's equal to root of 2 by pi integral from 0 to infinity f of x cos sx dx. Now here are few important integrations that we may require in this session. That is integral from minus infinity to plus infinity sin x by x dx is equal to pi. This is for integral 1. Integral 2, integral from 0 to infinity sin x by x dx equal to pi by 2. Third one, integral from 0 to infinity e to the power minus ax into cos bx dx equal to a divided by a square plus b square. Fourth one, integral from 0 to infinity e to the power minus ax into sin bx equal to b divided by a square plus b square. Fifth one, integral from minus infinity to plus infinity e to the power minus of ax square plus bx plus c is equal to root of pi by a e to the power b square minus 4ac divided by 4a. Sixth one, integral from minus infinity to plus infinity e to the power minus ax squared into cos bx equal to root of pi by a e to the power minus b square divided by 4a. Integral from 0 to 2 pi cos nx dx is equal to 0. Integral from 0 to 2 pi sin nx dx equal to 0. Integral from 0 to 2 pi cos square nx dx equal to pi. Integral from 0 to 2 pi sin square nx dx equal to pi. Integral 0 to 2 pi sin nx into sin mx dx equal to 0. Integral from 0 to 2 pi cos mx into cos nx dx equal to 0. Cos n pi is equal to minus 1 whole to the power n, and sin n pi is 0. Integral 0 to infinity e to the power minus ax dx equal to integral from minus infinity to 0 e to the power ax dx equal to 1 by a. Integral from minus infinity to plus infinity e to the power I kx dx is equal to delta of x. Scaling property of the Fourier transform. So now suppose we have the function f of x and we are taking the Fourier transform f of x equal to, we are getting the Fourier transform f of s, which will be given by 1 by root of 2 pi integral from minus infinity to plus infinity f of x e to the power isx dx. Now what the scaling property says that if the Fourier transform of f of x equal to f of s, then Fourier transform of f of ax equal to f of s by a into 1 divided by a, or you can write it as 1 by a f of s by a. Now we have another theorem that is called shifting theorem, which says that if the Fourier transform of f of x equal to f of s, then Fourier transform of f of x minus a equal to e to the power is a into f of s. Another theorem we have, that is the modulation theorem. Modulation theorem. Fourier transform of f of x into cos ax equal to 1 by 2 into f of s plus a plus f of s minus a. We know that the Fourier transform of the function f of x, that is Fourier transform of the function f of x, is equal to 1 divided by 2 pi, which is under root integral minus infinity to plus infinity f of x into e to the power isx dx. That means when you want to change from x domain to s domain, this is equal to Fourier transform of the function f of x, which is equal to f of s. Now if you want to find out the Fourier transform of the first derivative of the function f dash of x, this will be equal to 1 divided by root of 2 pi integral from minus infinity to plus infinity f of x e to the power isx dx with a minus is in the front. So this will be equal to minus is into f of s, because this particular function is nothing but the f of s. So now if you want to find out the Fourier transform of the second derivative of the function f of x, so you write f double dash of x, the Fourier transform, equal to minus is to the power 2 into f of s. For the third derivative, Fourier transform of f triple dash of x equal to minus is to the power 3 f of s. Now in general we can write the nth derivative of the function, its Fourier transform f n of x equal to minus is all to the power of n times f of s. Now if it is in the k domain, that means you are moving from x domain to k domain, the Fourier transform of nth derivative of the function f of x is equal to minus ik all to the power n into f of k. So this is the idea. For the derivative, you have to take minus I into whichever is the domain, that is here if it is s domain, minus I s all to the power whatever is the order of the derivative. If it is 1, 1, if it is 2, we have to put 2. So in general we can write like this: the Fourier transform of nth derivative of the function f of x equal to minus is to the power n into f of s. Fourier transform of Dirac delta function. Now that is the Fourier transform of delta of x is equal to 1. The Fourier transform of the first derivative of Dirac function, that is Fourier transform of delta dash of x, will be equal to minus is all to the power 1 into Fourier transform of delta of x. So this will be equal to minus is to the power 1 into 1, that's equal to minus is. So Fourier transform of nth derivative of the delta x will be equal to minus is to the power n into 1, so which is nothing but minus is all to the power n. The Fourier transform of some of the special functions or some typical functions can also be mentioned here, which are the Fourier transform of the function e to the power minus ax square. Now the Fourier transform of this function when moving from x to s domain, we can write it as 1 divided by root of 2 pi into root of pi by a e to the power minus s square divided by 4a. Now Fourier transform of 1 divided by x square plus a square equal to 1 divided by root of 2 pi into pi by a e to the power minus sa. Fourier transform of e to the power minus a mod x is equal to 1 divided by root of 2 pi into 2a divided by a square plus s square. Now you can also simplify all these equations, because pi and pi is there, here also pi and pi, but I recommend you to learn in this way because there is enough common terms in all the three, which is 1 by root 2 pi, which you will find it in the Fourier transform of certain function. For example, as we are writing the Fourier transform of some function f of x, it is equal to 1 divided by root of 2 pi integral from minus infinity to plus infinity f of x e to the power isx dx. So this is equal to f of s. So yes, definitely this 1 by root of 2 pi is a constant, which you find in almost all cases. Fourier series. Suppose we have a function f of x which is periodic in nature. If this is periodic, we can write the function f of x is equal to f of x plus a, where a is the periodicity. Then we can write the function f of x as a combination of sine and cos. So we can write the function f of x as f of x is equal to a naught by 2 plus sum over n an cos nx plus sum over n bn sin nx. Now if the function f of x is periodic in the range 0 to 2 pi, a naught value is equal to 1 by pi integral from 0 to 2 pi f of x dx. An value is equal to 1 by pi integral from 0 to 2 pi f of x into cos nx dx, and bn is equal to 1 by pi integral from 0 to 2 pi f of x into sin nx dx. Suppose the function f of x is periodic in the region minus pi to pi, then we have the function f of x, which can be written as a naught by 2 plus sum over n an cos nx plus sum over n bn sin nx. An is called the cos term and bn is called the sin term. Now if this is the periodic is in the range minus pi to pi, then we have the integral, that is a naught is equal to 1 by pi integral from minus pi to pi f of x dx, and similarly an is equal to 1 by pi integral from minus pi to pi f of x into cos nx dx. Bn is equal to 1 by pi integral from minus pi to pi f of x into sin n pi x, sin nx dx. Now you can see here that the limits are even, that means from minus pi to pi, here also minus pi to pi and minus pi to pi. Now since the limits are even, and suppose if, now you can write some if here, if f of x is an odd function, f of x is an odd function and the limits is even, then a naught value will be equal to 0, right? Similarly, in the case of an, a naught, an, the limits are minus pi to pi, which is again even. F of x is an odd function and this is an even function, then the product of odd and even function is again an odd function. Thus an will be also be equal to 0, and bn you can write it as integral from, instead of from 0 to pi, you can write it as 2 by pi into 0 to pi f of x into sin nx dx. Okay. If the function f of x is periodic in the interval either from minus L to plus L or 0 to 2L, then we can write the constants a naught as equal to 1 by L integral from 0 to 2L f of x dx. An is equal to 1 by L integral 0 to 2L f of x into cos n pi x by L dx. Bn is equal to 1 by L integral 0 to 2L f of x into sin n pi x by L dx. So in general we can write the function f of x equal to a naught by 2 plus sum over n an cos n pi x by L plus sum over n bn sin n pi x by L. As we have discussed in the case of the periodicity from or in the periodic in the range minus pi to pi, we can also extend this to minus L to plus L. In that case, writing down the function f of x is equal to a naught by 2 plus sum over n an cos n pi x by L plus sum over n bn sin n pi x by L. Now a naught is equal to 1 by L integral from minus L to plus L f of x dx. An is equal to 1 by L integral from minus L to plus L f of x into cos n pi x by L dx, and bn is equal to 1 by L integral from minus L to L f of x sin n pi x by L dx. Now again we can write if f of x as odd, then a naught is equal to 0, an is equal to 0, and bn equal to 2 by L integral from 0 to L f of x into sin n pi x by L. So there will be only sine terms in this series. Fourier series of Dirac delta function. The function f of x is equal to a naught by 2 plus sum over n cos nx plus sum over bn sin nx. Here a naught value is equal to 1 by pi an is equal to 1 by pi cos na bn is equal to 1 by pi sin na. So you can write the function f of x is equal to 1 by 2 pi plus 1 by pi into cos n of x minus a. So this is the function which is equal to direct delta function. So delta of x is equal to 1 by 2 pi plus 1 by pi into cos n of x minus a.